good afternoon, good evening from wherever you're watching from. Welcome to LIMESTONE Kenya. This is your trusted YouTube channel for quality syllabus-based learning in geography that is tailored to Kenya's curriculum. Now, at LIMESTONE Kenya, we are passionate about integrating the normal learning with technology so that we can make these subjects easier, relatable, exam ready for learners across the country. And so whether you're a student who is preparing for the exams, you might be a teacher looking for additional content to support your teaching, or maybe you're a parent guiding your child through this subject, then this channel is for you. So in case you're new here, please go and watch my previous videos. Watch this video to the end, leave a like, share this video with your colleagues, your friends, the parents, and above all, you also appreciate your feedback. So you can drop your feedback in case you need a room for improvement, you need a topic for us to do for you. You can leave it in the comment section. Also remember to turn on your notification bell so that you don't miss on any important tutorial that we post. So like, share, subscribe so that we can empower learning everywhere in this country. So in today's discussion, you're going to talk about a very crucial topic, that is action of water in limestone areas. And under action of water in limestone area, our area of focus today is the underground water and karst scenery. Now, in order to make this subject more relatable and understandable, we are going to use what we call narration. At some point, we'll use presentation in our discussion. So stay tuned. Watch this video to the end, and at the end of the day you can leave a feedback through the comment section. So we'll start by the definition of terms. Now, underground water and karst scenery. Now when you look at this topic, underground water and karst scenery, it entails two areas of discussion. We will discuss underground water in this first session, and then in part 2 of this video we'll focus on the karst scenery. Now when you talk about underground water in a layman's language just refers to that water that exists below the surface of the earth. It is just that water that exists below the surface of the earth and is normally contained in the available air spaces in the soils and in the rocks beneath the earth's surface. Are we together? So for a comprehensive definition, it is water that is found in the pores of the permeable rock layers under the ground and above the impermeable rock layer. Are we together? It is water that is found in the pores of the permeable rock layer under the ground and above the impermeable rock layers. Are we together? So it is normally contained in the available air spaces of the soil, in the rocks, which are beneath means below the surface of the earth, and which are above an impermeable rock layers. This one will stand out as we proceed. Now, having looked at that, then we ask ourselves very critical question: where does this underground water come from? So that one will lead us to discuss the sources of the underground water. And when we talk about the sources of the underground water, we have 4 main sources that we are going to look at. Now, one of the main sources of the underground water is what we call the rainwater. Now when you talk about the rainwater, this is water which normally infiltrates and percolates into the lower parts of the rocks, especially when it is raining. At that point, when it's raining, we have that amount of water which moves underground vertically into the available air spaces within the rocks, and they are collected. At the end of the day, they form part of what we call the underground water. The second source of the underground water is what we talk about the meltwater or the melting ice. Now, meltwater, this is that water which infiltrates the ground and eventually percolates through the rocks at the point when the snow during summer melts. Are you together? Or in other words, it changes from solid into liquid form, that water at the end of the day it will infiltrate underground to form part of the underground water. The other source of underground water, we have the lakes, we talk about the seas, rivers, and some point to talk about the swamps. And when you talk about this, normally through what we call the underground seepage, through that seepage, the process of underground seepage, some of the water will find their ways into the rocks underground to form part of what we call the underground water. And finally, we have what we call the magmatic or plutonic water. And from the term magmatic comes from that magma, and plutonic, you remember the concept of volcanicity, the plutonic rocks. Now, this is water that normally gets trapped beneath the rock surface during the process of volcanicity. Are you together? It is that water that is trapped in the rocks during the volcanicity. Are we together? So those are the four main sources of underground water. And just to wrap that up, we have, so in case you have a question asking you give four sources of underground water, talk about rainwater, meltwater, or what you call the melting ice, the lakes, seas, rivers, or swamps, and then you have the magmatic water. Now, as we move on with this topic, there are some fundamental terms that you're going to talk about that are very important. You come to understand them, you know their differences as we move along. Now, one of the terms that we are going to talk about to know their differences is the term infiltration. Now, when you talk about infiltration, you talked about it when you're talking about the hydrological cycle. So I believe at this point you have an idea of what infiltration is and what percolation is. And just as a reminder, infiltration is the sinking of water vertically into the soil or surface of the rock through the pores, cracks, or joints. So when you talk about infiltration, the key thing that you need to know, it is normally the vertical sinking of water into the surface of the rocks. What about percolation? Percolation, on the other hand, it is the movement of water downwards and in a horizontal way inside the rocks of the soil. So for the percolation, it is the horizontal movement of water, while the infiltration, it is the vertical. Are we together up to that point? The other concept that you need to look at is the difference between the porous and the pervious rocks. When we talk about the porous rocks, these are just the rocks that have pores or air spaces which are capable of absorbing water and allow the infiltration to take place. So these are rocks which have air spaces. We can talk about them being spongy-like, and through that they allow water to pass through them, what we call now infiltration. Right together, and it passes through them, it also gets absorbed. Pervious rocks, on the other hand, these are rocks that have cracks, joints, or fissures. So pervious rocks are rocks with cracks and joints, which allows water to percolate through, while porous rocks are rocks with air spaces which absorb water and allow infiltration to take place. The other aspect that you also need to focus on in this topic is the difference between the effluent streams and the influent streams. And basically, effluent streams are those underground streams which are normally supplied with water from water table above them, while influent streams are those underground streams which are normally supplied with water from water table below them. In short, the effluent stream normally flow below the water table, while the influent streams, they flow above the water table. Having talked about those fundamental factors, we are also going to look at what we call an aquifer. So an aquifer is a rock which cannot be penetrated by water. In other words, an aquifer is another term that we use to refer to as an impermeable rock. So an aquifer is that rock which cannot be penetrated by water. In other words, is what we call an impermeable rock. Then on the other hand, the other term that you need to look at is an aquiclude. Aquiclude is a rock, more of a clay, which allows water to enter but does not allow it to pass through it. It allows water to enter but does not allow water to pass through it. Other terms we're going to look at later in this discussion. You have the water table, Artesian, Artesian basin. We are going to look at them as we move on. Having talked about that, we now want to look at factors which influence, or factors, conditions which are necessary for the occurrence of underground water. And you might get a question like this: explain the factors that influence the existence of underground water. So simply, these are just the conditions which are necessary for the underground water to be there. Are you together? So it's important to know that much of the groundwater normally originates from the surface of the earth. That water that is normally found below the earth's surface, it normally originates from the surface of the earth. And the occurrence of this underground water, it depends on several factors. Are you together? And these factors are normally related to what we call the rate of infiltration. So much of the underground water normally originates from the surface of the earth, and the occurrence of the underground water, it's important to note that it depends on factors that influence the rate of infiltration. So these are the factors that you want to look at. Now, the first factor is amount and nature of precipitation. Amount, the nature of precipitation or rainfall. Now, when you look at this factor of precipitation, it's important to look at it in three phases. We look at precipitation in terms of intensity, we look at precipitation in terms of duration, and we also look at the precipitation in terms of reliability. Are we together? And when we talk about the precipitation, the amount of rainfall that normally infiltrates the ground, it solemnly depends on the type in the amount and intensity of rainfall, whereby we say light rain which falls over a long period of time normally gives time for infiltration to take place more than heavy downpour which is short-lived, hence saturate the surface of the earth, blocking the passage through which the water infiltrates, hence less infiltration takes place. In short, what I'm trying to say is that the higher the amount of rainfall that falls within a short period of time leads to high amount of surface runoff, hence there will be minimal amount of infiltration that will take place, and the end result of this will lead to low amount of underground water. Light amount of rainfall, so small amount of rainfalls which falls over a long period of time, normally tends to give time for the ground to allow for infiltration, and this will imply that at the end of the day there will be a lot of infiltration taking place, contributing to more amount of underground waters. It is also important to note that areas with reliable rainfall normally have underground water than those with unreliable rainfall. If a place receives reliable rainfall, at the end of the day it will have adequate amount of underground water as compared to a place that receives unreliable rainfall. In the case study, you can take maybe areas of Mount Kenya and the northern part of Kenya. Are we together? So just as a way of a quick recap, little rainfall results into little or no infiltration, hence low amount of underground water, while heavy rainfall within a short period of time leads to more surface runoff, which leads to little infiltration, hence low amount of underground water. Heavy rainfall, on the other hand, saturates the surface, hence blocking air spaces, hence reducing the rate of infiltration, leading to low amount of underground water. And in this case, we talk about heavy rainfall moving within a short period of time. On the other hand, high rainfall, now this one is in terms of intensity, high rainfall leads to high rates of infiltration, hence high amount of underground water. Rainfall over a long period of time also results in more amount of infiltration, hence replenishing the underground water. So I hope you have understood that first factor. The second factor that you want to look at is the slope or the gradient. Now, when you talk about the gradient, is just the nature, the steepness and the gentleness of the surface of the earth. And in this case, we look at the steep slopes normally tend to reduce the infiltration, and since much water is lost through the surface runoff, while on gentle slopes, water remains longer on the ground, allowing infiltration to take place. So when you talk about the gradient, a flat or a gentle gradient, it results to more infiltration, since water is given enough time, sufficient time to sink or infiltrate underground to form underground water. On the other hand, when you talk about the steep slope, there is more surface runoff, which leads to little infiltration, and the end result of this is minimal underground water. The other factor is the vegetation. Now, when you talk about the vegetation, now presence of vegetation, normally the vegetation cover normally tends to reduce the speed at which the water moves on the earth's surface. So when you look at this factor of vegetation, vegetation normally provides the shades on the ground. Number one is to reduce the evaporation, hence increasing the rate of infiltration, and this the overall result will increase to more amount of underground water. The presence of vegetation cover also reduces the speed of the falling raindrops, hence reducing the speed of the surface runoff. As a result of this, it holds water, allowing time for infiltration to take place, and when this water sinks, the overall result is that there will be more amount of underground water. On the bare grounds, on the other hand, there is a lot of surface runoff, which gives very little time for infiltration to take place, hence reducing the amount of underground water. So vegetation covers, a way of recapping this, is that in areas with vegetation cover, number one, the vegetation cover will reduce the speed of the surface runoff, giving ample time for infiltration to take place, hence more amount of underground water. Also, the presence of vegetation tends to minimize the rate of evaporation, and when the rate of evaporation has been reduced, it means a lot of water will be infiltrated, hence will contribute to more amount of underground water. On the negative bit, when an area without vegetation cover, bare grounds, normally has high amount of surface runoff, giving little time for infiltration to take place, and the end result of that is that there will be reduced amount of underground water. The other factor is the level of ground saturation. Now, when you talk about ground saturation, is that dry soils normally absorb more water to make underground water, while the saturated and the wet soils have little infiltration. So when the soil is dry, it tends to have that hunger for water. So a high amount of infiltration will take place, as opposed to an area that is already soaked, saturated, where little infiltration will take place. And the other factor, we have the evaporation rate, whereby we say high evaporation rate leads to less infiltration, hence reducing the underground water, while low evaporation rate leads to more water infiltration, thus increasing the amount of underground water. So up to that point, maybe if you have a question, you can drop it in the comment section, or maybe if you have an area that you want further clarification, you might also leave it in the comment section, and our team will get back to you. Now, at this point, I want us to differentiate between two terms which are very critical in our next area of discussion, and this one is the difference between aquifer and a water table. And as we mentioned, an aquifer is a permeable rock layer above an impermeable rock layer, which is permanently saturated with water. An aquifer is more of an impermeable rock. It's more of an impermeable rock. It's a permeable, no, sorry, we withdraw that. An aquifer is more of a permeable rock, not impermeable. It is more of a permeable rock layer above an impermeable rock layer, and it is normally permanently saturated with water. Water table, on the other hand, is the upper level of water saturated zone in the permeable rock layer. It is the upper level of water saturated zone in the permeable rock layer, and we are going to see this one come out as we continue with our discussions, especially when we be talking about the zones of the groundwater. Now, having talked about now the definition of underground water, the sources of the underground water, the factors that influence the existence of the underground or the phreatic water. Now, we ask ourselves, what are some of the features that can be found by underground water? And we have four main features. Number one, we have the springs. Number two, we have the wells. Number three, we have what we call the Artesian basins. And number four, we have the underground or subterranean streams. So we have the springs, the wells, the Artesian basins, and the subterranean streams. Now, we have a diagram there that is showing the zones of the underground water. We have a diagram there that is showing the zones of the underground water. Diagram showing the zones of the underground water, and from there you can see the soil water belt. Then you can see where the impermeable rock is, and also you can see zone number 1, zone number 2, and zone number 3. Zone number 1, zone number 2, and zone number 3, whereby zone number 1 is the zone of permanent saturation. Zone number 1 is that zone that is above, immediately above the impermeable rock, is the zone of the permanent saturation. And it's important we just know that all rocks and pores within this zone are permanently filled with water. All rocks along this zone 1 are normally permanently filled with water, and this zone is also called the phreatic zone. It is important to know that the zone of permanent saturation is also known as the phreatic zone, and all pores are permanently filled with water. Then you go to zone number 2. Zone number 2 is the zone of intermittent saturation. Zone number 2 is the zone of intermittent saturation, and it's important to know that here the water content normally fluctuates based on the seasons. You find that during the rainy season the rocks are saturated, while during the dry period the layer is unsaturated. So this zone normally fluctuates in terms of saturation based on the seasons. When the seasons is when you have high amount of rainfall, or during the rainy season, the content is normally high. The content of water is normally high within this zone, and during the dry season the content of water is normally very low, or it's completely unsaturated. Then you have zone number 3. It is the zone of non-saturation, and it's important to know that it's a zone of rock layers that is found immediately below the surface, and its permeable layer, it allows water to pass through but never remains in the pores for a long period of time to saturate the rocks. And it's important also to know that the top part of this zone is also called the soil water belt. So zone number 3 is the zone of non-saturation. This is the zone that is immediately below the surface of the earth. It is a permeable layer, which simply means it allows water to infiltrate, and water passes through but never remains in the pores for a long time in order to saturate the rocks. And it is also what we refer to it as a soil water belt. So that is the diagram showing the zones of the underground water. We have the zone of non-saturation, we have the zone of intermittent saturation, you have a zone of permanent saturation, and apart from that, you need to know how to draw the diagram. You need to know how to draw and label the diagram. In case you have a question up to that point, you can leave a question on the comment section. Now, having noted that on the diagram, now we want to describe the characteristics of these three zones. Now, the zone of the permanent saturation, that is the zone immediately above the impermeable rock. Now, one of the characteristics of this zone is that this zone, it lies directly above the impermeable rock layer. This zone is permeable. Itself, it's permeable in nature. It is a permeable rock layer that holds water above the impermeable rock. It has pores and air spaces in this zone, and also the upper level in this zone has permanent water table. The upper level has permanent water table, and from the diagram you can see immediately the demarcation between zone 1 and zone 2 is a permanent water table. So it is a zone of permeable rock layer that holds water above the impermeable rock layer. It has pores and air spaces that are always filled with water, and the upper level of this zone has a permanent water table. And from the diagram you can see that indeed it has a permanent water table on top of it. Zone number 2, that is the middle zone, the intermittent or the seasonal saturation. We said it is seasonal because during the high rainy season it is highly saturated. On the dry rainy season it is less saturated. So it is a part in the permeable rock layer above the zone of permanent saturation. Water in this zone normally fluctuates seasonally, as I've explained. It is saturated with water during the rainy season and dries up during the dry season. Then the zone of non-saturation, on the other hand, is also called the zone of aeration. It is the uppermost part of the permeable rock layer which does not hold water. It doesn't hold water. It is permeable, but it doesn't hold water, in that water sinks through it but does not hold water. It is the top, or it is the topmost part of the soil, also known as the soil water belt. I hope you're together to that point. If you have a question, you can leave it on the comment section. Now, I want to talk about what we call a spring. And we start with the definition. Now, a spring normally is just a point where the ground water flows naturally onto the land. It is a point where water just naturally flows into the land. And before we talk about the spring, I would like us to define what we call a water table. I mentioned the water table as that the topmost part of the zone of permanent saturation. And just to define the water table, this is the upper limit of the phreatic zone, or the zone of permanent saturation. The water table is the upper limit of the phreatic zone, i.e. it is the zone of the permanent saturation. So at this point, it's normally permanently saturated, and it's the uppermost part of the zone of permanent saturation, forming the boundary between the zone of permanent saturation and the zone of intermittent saturation. The other thing that I would also like us to define is an aquifer, and this is also a permeable rock underlain by impermeable rock, and which is permanently saturated with water. And it's important also to note that the presence of the groundwater leads to the formation of spring wells and Artesian basins. That now we are going to discuss it. So an aquifer, it is a permeable rock which is underlain by impermeable rock, and it is normally permanently saturated with water, a permeable rock which is underlain by impermeable rock, and it is permanently saturated with water. Now, having talked about that, now we can start talking about what a spring is. Now, a spring is a point where the underground water flows out naturally as the water table is exposed to the surface along a slope. It is a point where the underground water flows naturally onto the land or onto the earth's surface. That point where water flows naturally onto the earth's surface. That point whereby underground water flows naturally onto the earth's surface, and it occurs where the water table is exposed to the surface along a slope. Where it occurs where the water table is exposed on the surface along a slope. Now, springs may occur or may form in several ways. Now, springs may form in several ways. And in this discussion using diagrams, we are going to describe three conditions that lead to the formation of springs. We are going to discuss three conditions that lead to the formation of springs. And just before we go through the diagrams, I would just like to mention that springs may form in any of the following ways. And one of the ways is where the permeable rock overlies an impermeable rock layer. Where the permeable rock lies on top of an impermeable rock layer. That is one instance. The second instance is where a well-jointed rock on a hilly country, where we have a well-jointed rock on a hilly country. And in this case we say it's when water enters a well-jointed rock on a hill and saturates them. It then occurs that it then comes out of the ground at a point where that water table is at the same level as the ground surface. And that is going to come out clearly when we look at the diagram. The other way where the spring may form is where an aquifer lies on upper side of a dike which outcrops. Where an aquifer lies on the upper side of a dike which outcrops. And the end result of this is that a spring may form at the line where that dike and the aquifer intersect. So that point of intersection of the dike and the aquifer, a spring may end up forming. And lastly, the fourth way in which a spring may form is where a limestone escarpment is underlain by an impermeable layer of a rock. A spring may form at the foot or in an area where a limestone escarpment is underlain by an impermeable rock. Now, back to our discussion. From the diagram, you can see where the permeable rock lies above the impermeable rock, and we say that rainwater percolates and saturates the permeable rock. A spring forms where the permeable rock and the impermeable rock meet to the surface, and this may form a line of spring at the base. And you can see from the diagram we have a permeable rock, we have the water table, we have the water saturated zone, and at that point where the zone of permanent saturation is meeting the impermeable rock and is exposed to the earth's surface, a spring emanates from that point. The point where the water saturated zone is meeting the impermeable rock exposed to the ground surface, the spring emanates from there. The other way is where there is a well-jointed rock on a hilly country, and we say that rainwater percolates through the joints and saturates the rocks. Water comes out where the joints open up on the surface to form a spring. It may also form a line or spring at the base of the slope called vow Vauclasian spring, the Vauclasian springs. And you can see the well-jointed rocks. When you talk about percolation taking place, you can see where the water table is, and at that point where the water table meets the earth surface, the spring emanates. That point where the water table meets the earth at an open point, the water table will emanate. Then where the dike cuts across the layer of the permeable rock, where the dike cuts across the layer of the permeable rock, and you can see that the water table is raised to the surface, and that point of intersection, where the dike and the aquifer are intersecting. Look at the dike and where the aquifer, the zone of permanent saturation, where the permeable rock is and where the dike is. At that point of intersection, the spring emanates from that point. The spring emanates from that point. And then the fourth point is where the limestone escarpment is underlain by the impermeable rock. And under this, you can just see from the diagram the limestone escarpment. We have the water saturated layer, and at that point of intersection where we have the limestone escarpment and where the water table is meeting the limestone escarpment, we have a spring emanating. At that point. So up to that point, I believe we understood various ways how a spring will form, and in case you have a question, you can leave it in the comment section. The other feature that you want to talk about is a well. And during our next discussion is going to pick up from there. So we still have various features to talk about. We have a well, we have an Artesian basin that we need to cover. So we still have quite a lot to cover, but for today, I want our discussion to end with that. Please, as I mentioned earlier, remember to like this video, share it, leave your comments, and above all subscribe. So in our next discussion, we are going to talk about the well, the Artesian well. We'll discuss about the Artesian well. We're going to give about the importance of the underground water to human activities, and also we are going to explain factors. We are going to let's talk about what is a well. Now, a well, it is a hole that is dug underground to reach the water saturated or permanently saturated water zone, what we call an aquifer, such that it extends. Let me take that again. So a well, it is a hole dug into the ground to reach the water saturated permeable rock, what we famously known as the aquifer, such that it extends below the water table, resulting in water oozing out and collecting in a hole. Also, I want us to define what we call an Artesian basin. And the Artesian basin is more of a saucer-shaped depression. Which consists of a layer of permeable rock that is sandwiched between two layers of impermeable rock. And it's important to know that the whole system of the rocks around the basin normally form a syncline. That's why we call it a saucer-shaped. And when it forms a syncline, one or both ends of these permeable rocks are normally exposed to the surface. So the saucer-shaped depression normally has a layer of the permeable rock sandwiched between two layers of impermeable rocks, on which one or both ends are normally exposed to the surface. And in that circumstance, if a well is sunk into the aquifer of an Artesian basin, normally water will normally come to the surface through what we call the hydraulic pressure, so long as the mouth of the well is below the water table, and that hole that is sunk into the aquifer is what we call an artesian well. So just to take that one again, is that an artesian basin is a basin that is saucer-shaped depression consisting of a layer of permeable rock that is sandwiched between two layers of impermeable rock, and the whole system of the rocks around the basin are normally syncline, exposed on one or both ends to the surface of the earth. And when you sink a hole on this saucer-shaped depression, the water normally reaches the earth's surface by what we call the hydraulic pressure, as long as the well is below the water table. And that deep hole that is sunk is what we call an artesian well. Having talked about that, having defined what an artesian basin is, now we want to explain the ideal conditions. The ideal conditions that are necessary for the occurrence of an artesian well. Explain conditions that lead to formation of artesian well. And number one, the aquifer must outcrop in a region which is source of water. We must have an aquifer. And just to look at our slide there, the presence of permeable rock, which is sandwiched between two impermeable rock layers to hold the water. It's very important that you have a permeable rock that is sandwiched between two impermeable rock layers. Number two, the permeable rock must be exposed to the surface to allow water intake, either on both sides or on one side. It must be exposed to the surface. Then number three, the permeable rock must outcrop in a region, as I mentioned earlier, the permeable rock must outcrop in a region of adequate water supply, or high rainfall region, or a lake bed, in order to absorb water. So that permeable rock must outcrop in an area where we have adequate water supply, and so that it can absorb that rainfall water, or in a lake bed in order to absorb that water. Then the permeable rock layer becomes saturated with water, forming an aquifer. Then it's also important to know the entire rock structure and the permeable rock must form a syncline water, so that the syncline nature is to allow for enough pressure, so that to allow this water to flow out naturally through hydraulic pressure. Then the artesian well must be sunk to reach below the water table. The artesian well must be sunk to reach below the water table for it to have water permanently. And also the mouth of the well must be lower. The mouth of the well must be lower than the water intake area for water to flow out naturally through what we call the hydraulic pressure. And then below there we have a diagram showing how an artesian well looks like, how an artesian basin looks like together with an artesian well. You can see how it is exposed on both ends. You can see the water saturated zone. You can see the water table where it is. You can see where we have the impermeable rock layers that are sandwiched, the layer of the permeable rock layer. You can see how it has been sunk, and now water is coming out naturally through the artesian well. Having talked about that, now I want us to talk about the importance of underground water to human activities. And the first importance of underground waters, we'll go through them very fast, that they forms springs, which are source of rivers, and these rivers normally provide water for domestic and industrial use as well as agriculture. I think that one is more easier to understand. So the water that we get from this spring, we use them at home for domestic purposes. Some we use them in the industry for the processing, and agriculture maybe for irrigation. also for mixing of chemicals and whatever the process that water can be used for in either of these places. Then the second importance of this underground water to human activity is that water from the springs can be piped to distant areas to serve towns or even cities. For example, water from Zima Springs serves Tsavo National Park and is piped all the way to Mombasa. So we can tap this water and use it in far places. The other importance is that the underground water from the oases and wells that provides the water for the domestic and industrial and agricultural uses. You have talked about that. Underground water also sustains the growth of plants, because remember the plants require water for their processes, so it provides water for the same. Springs, oases, and wells also attract settlement, leading to development of towns. For example, when you look at ancient towns like Gedi in Kilifi County, they were established in areas where water was obtained from the wells. It ceased to exist when the wells dried up. So it's important that it also influences settlement and the development in that case. And also we talk about the hot springs and glaciers formed by underground water during volcanicity are used for geothermal power and heat the homes. So we get the electricity from them, and also to heat homes. Also the hot springs deposit dissolved minerals, salts on the surface, which are exploited for economic purposes. The other importance is that some of the hot springs from health SPS, which are medicinal values, and to treat skin. So I don't know how this happens, but some claim that these hot springs normally provide water for medicinal use. I don't know how true that is, subject to confirmation. And then some hot spring and geishas also help in making some lakes fresh by draining away the excess salts. We talk about Lake Naivasha. So having talked about that, I think that brings us to the end of today's discussion. So our next phase will be focusing on the karst scenery, and I would just like to take this opportunity to thank you for watching this video till the end. If you find this video important, please share it with your learners, share it with the parents, share it with your fellow colleagues. Like this video, leave a comment, and I'll really appreciate if you leave a comment for a room of improvement. If you see there is a correction somewhere, we really appreciate your feedback. And above all, subscribe. Support me by subscribing. We're still on the road to 1,000. See you in the next session. Thank you so much.